Hello everyone and welcome back again to another new video of DeltaMind. Today in this video we will be moving towards our next destination of our complex analysis journey, which is complex numbers. As you already know, in our previous video we have discussed about imaginary numbers. So I'm assuming that you have some basic knowledge of imaginary numbers. So without wasting time, let's start the video. So let's begin with the most fundamental question. What are complex numbers? Well, a number z is called complex when z can be represented in the form z equals to x plus iy. Here, x is called the real part of the complex number and I times y is called the imaginary part of the complex number. And x and y both are real numbers. Well, just like the real numbers can be represented on the real number line, complex numbers are represented on the complex plane. Well, the complex plane is similar to the Cartesian plane we use in algebra, but here the x-axis represents the real part of the complex number and the y-axis represents the imaginary part of the complex number. In this complex plane, we can plot out any complex number and the graphs of complex function. Well, we can also represent complex numbers using its polar form. Like if we want to represent a complex number x plus iy in its polar form, first thing we would need to find is its modulus. So mod z equals to under root of x square plus y square, and the second thing we would need is its argument. So argument is essentially its angle from the origin. So to find it, we can use the equation tan theta equals to y by x. Take tan inverse both sides, theta equals to arc tan y by x. Then we can write r cos theta plus I sin theta, where r is mod z and theta is the argument we just found. Also, we can use the Euler's formula e to the power I theta equals to cos theta plus I sin theta to represent it in its exponential form, r e to the power I theta. This is called the complex numbers exponential form. So now let's take a very quick example. Let's say z equals to 1 plus I root 3. So to convert it into its polar form, first we would need to find its modulus, which is mod z equals to under root of 1 plus root 3 squared, or which is mod z equals to 2. And then we need to find its argument. So tan theta equals to root 3 or theta equals to arc tan root 3, which would give us theta equals to pi by 3. Now let's substitute it into the formula we discussed earlier, r cos theta plus I sin theta. So it would be here r is mod z, so it's gonna be 2 times cos pi by 3 plus I sin pi by 3. Congratulations, you have converted your first complex number into its polar form. So using this knowledge, can you try finding the polar form of z equals to 1 plus I? Give it a try and let me know in the comments. Alright, now as we know the basics of complex numbers, we must now know how to do the arithmetic operations on complex numbers. So first, let's begin with addition. Say z1 equals to x plus iy and z2 equals to a plus ib. If z equals to z1 plus z2, then z would be equal to a plus x plus I times b plus y. It's quite simple, just add the real parts and add the imaginary parts. And then let's move on to subtraction. Subtracting is very similar to adding complex numbers. Say, considering the previous assumptions, if z equals to z1 minus z2, then z would be equal to a minus x plus I times b minus y. Oh. Alright, now let's move on to multiplication of complex numbers. Multiplying complex numbers is quite similar to multiplying real binomials. If z equals to z1 times z2, then z would be equal to x plus iy times a plus ib, which equates to xa minus yb plus I times xb plus ya. Now let's move on to the division of complex numbers. Well, the division of complex numbers is a bit more involved than the multiplication or addition subtraction of complex numbers. So now let's consider z equals to z1 by z2, or z equals to x plus iy by a plus ib. Now to simplify this expression, multiply the numerator and denominator of the expression with the complex conjugate of the denominator, which would give us a square plus b square by x plus iy times a minus ib. And we already have learned to multiply complex numbers, so we can easily solve from here to arrive at a final answer of the division. Alright, so that's everything you needed to know about complex numbers. Meet you in the next video. Until that time, bye.